que acende a sua vontade de começar algo? Tem uma faísca em você que te chama para empreender, investir, dar novos rumos para sua vida. E para todos os seus começos, você pode contar com Santander Select. Um banco mais pessoal, mais próximo, mais humano. Um time de especialistas com olhar atento para cada momento da sua vida. Porque você sabe, só quem já deu muitos passos está pronto para continuar começando. Santander Select. Começa em você, começa agora. Precisa aferir a pressão, medir a glicemia ou tomar uma vacina? Na Drogasil tem exames, testes e calendário vacinal completo. E o que é melhor, tem sempre uma Drogasil aí perto de você. É fácil, prático e rápido. Dá para ir entre uma música e outra. Procure nossos farmacêuticos. Quanto mais você conhece o que a gente faz na Drogasil, mais você se cuida.
Welcome to a bonus episode of the Race F1 Tech Show, or as it should probably be called today, the Autonomous Racing Tech Show, because this episode is all about the A2RL, the Abu Dhabi Autonomous Racing League. This is a brand new autonomous racing series featuring some fascinating technology, and I'm delighted to say that joining myself, Ed Straw, and Gary Anderson is one of the brains behind it, Dr. Tom McCarthy. So thanks for joining us, and of course the Abu Dhabi Autonomous Racing League is gearing up for its inaugural race event using cars from Japan's Super Formula Championship that are entirely autonomous, and this is just the start of a series of high-profile events that will showcase the development and evolution of this technology. The first race is later this month on April the 27th, and it'll be live on our YouTube channel. So we're getting very close to what will be a seismic event for motorsport. So it's over to you, Gary, to find out more from Dr. Tom McCarthy.
Hi, Tom. Good to speak to you, and I'm looking forward to seeing how this all unfolds. I'm from more of the normal, as we know it, racing world, I suppose you might call it, Formula Racing world, Formula 1, Formula 2, etc. So, one of the questions is, what is this racing event that you're putting on? What will it process like?
Okay, well, the process will be very familiar in terms of the surroundings and in terms of the car, of course, except for the big thing that there won't be a driver sitting inside in the car. Now, I guess that if I step back a little bit, in a sense, Gary, you're saying you're coming from motorsport. For me, I'm actually coming from research administration, not coming from motorsport at all. And I'm not a research engineer myself. So what we're doing here is motivated by what my company is doing. The company is part of the Abu Dhabi the Advanced Technology Research Council, ASPIRE. So role is to put in place programs that facilitated the diversification of the economy of Abu Dhabi into sectors like agriculture, transport, renewable energy. And in one way we do that is we look for big problems that we want to go out there and solve. And the big problem that we're trying to solve here is road safety. I mean, how do we get a situation where the average driving capability is better? An awful lot of the effort in the past quarter century has been into secondary safety. What happens after there's an accident? How do we make the outcomes better for those involved in the accident? We're focusing very much on primary safety. And in that respect, what we're trying to do is improve the average driving experience. Now, we're not going to go out and educate all the drivers. What we want people to do is we want people to trust in autonomous robotics and in AI to be a co-pilot with you in the car. Now, for us, motorsport has that focus on primary safety. And so we want to switch on its head what normally happens with production cars and actually use the process of motorsport to focus on how we can bring a focus on primary safety into road use. So to that end, what we want to do is we want to demonstrate what's actually potential of this technology by using the extreme motorsport on the track. Now, we're not going to get to a situation where you have the wheel-to-wheel racing of all cars starting on a grid together in year one, but we're moving towards a process where we can demonstrate that. And in the particular process this year, we're going to be able to demonstrate very significant achievements, both in the speed of the autonomous car and in the ability of autonomous cars to race against each other on the track on race day.
And how many cars are we going to see running at the same time on the track?
We have 8 teams in total competing, and up to now, the best that has been achieved is 2 cars on a track together, and our objective is to see 4 cars racing together on a track. That will be done over a number of days, where you have like regular meets, we have pre-qualifying and we have qualifying races, and on the final day itself we will have 2 types of races: the speed type qualifying races and the final race, where we seek to have 4 cars racing against each other on the track.
So will we see one car actually going to do a quick lap, one car at a time, going for a qualifying lap as such?
There will be the actual qualifying takes place a number of days in advance, where we seed the teams, and then we will also have attacker defender races going on, where 2 cars are attacking and defending, and that's done when we start by seeding the cars in the pre-qualifying race. That will be earlier in the week. And then they'll be divided into 2 groups, the odd group and the even group, and they will all race against each other, both in an attacking mode and a defending mode, and they will get points from that. They will then go on the final day, and not so much do a qualifying race, do speed races, so they'll be given attempts to put up their fastest lap and working against each other. And that will be a continuous process. The cars will be on track throughout about a 2-hour period of doing that. And then finally, the top cars on the attack defend and on the speed trials will qualify for the 4-car race, which will be the final race.
So why use a Formula car for this as opposed to, let's say, an electric road car joined into the technology that's in place right now for where road cars seem to be moving? Sure.
Well, first off, we're not using electric cars. We're using petrol cars, and I think for us the challenge here is, and it's the, I suppose we should put it, it's the heritage of motorsport over 100 years. Since the beginning of the auto industry, the attempt has been to test at the extreme of performance. So we want to test at an extreme of performance where no average driver is ever going to go. But if we can demonstrate it at the extreme, we believe there's a much greater chance of getting consumer acceptance. Because the real problem for autonomy is that the technology has moved ahead of consumers' acceptance. And in fact, consumer acceptance has gone backwards in recent years. Some of that, I think, arises from what I think is the overhyping of the idea of driverless cars, the overhyping of the idea of ADAS level 4 and ADAS level 5. And we want to reset. We want to reset to say, look, the future, the next quarter century is going to be about drivers marshalling and driving their own cars, but we want them to accept greater autonomous components in those cars to make that driving experience safer. And we believe you have to really push it to the extremes of performance to start getting that buy-in. Whereas if we'd use regular production cars, I don't think we'd achieve that.
Yeah, but it's, well, not going to dispute that, but it's the regular production car that the customer can buy. It's the
Sure.
regular car that the customer can relate to, because that's what they use. Racing cars have always been this highly sophisticated piece of kit anyway.
Yeah.
Never mind actually becoming autonomous. It's the road car that we're looking at here, the driving around the M25 in traffic, that needs to be able to cope with.
Absolutely, but I mean, what you do at the moment in the trying to put in components into those cars, and I've talked to the OEMs on this one, is they keep trying to put in extra cameras, extra LiDAR, and that creates a problem in and of itself. It creates a problem of too many signals and too much data coming in, which leads to the potential that there's conflict between that data. So what we're seeking to do is seeking not just to take a fixed car and fix set of perception components and push them to the extreme to see how the coders can actually develop a capability to respond and react in extreme circumstances. But as we go in future as well, we want to develop the car as a platform, as a laboratory in and of itself, where the ultimate goal must be we reduce the amount of perception that's used in cars, so we make it easier to do the sensor fusion, and at the same time we enhance the capability of the programming. I think there is a distance to go before you could be happy to say that. Before I'd be happy to say that I'm happy to share the driving with a co-pilot. And I think we really do need to be able to demonstrate in extreme sporting conditions the capability and the potential of doing this.
So no matter what the vehicle is, can you run us through some of the technology that's used to actually, let's say, take this car around a racing track on a lap,
Sure.
and obviously to exploit as much lap speed out of it as possible? How do you go about doing that?
Okay, so we start with a one design car, and that was very important for us, that we could isolate just the programming components as the only components that would be different as between the cars. So we take that Super Formula car, and then we take the driver out. Now, obviously, the first thing you got to do is you got to put in some form of actuation into the car. How do you accelerate, brake, and steer? So we had to develop a system of drive-by-wire there. So we worked with Mechanica 43 in order to develop the braking, the steering, and the acceleration systems. And they're the first thing that go in. And then they're operated from the main computer through a drive-by-wire system. Now, sitting on top of the car, then we have, I guess we would say, four main elements for figuring out where you are and what's around you. We have the GPS components, so we have two antennae in the front and rear of the cockpit. We then have 7 cameras, 3 on either side, looking forward and sideways, and 1 looking backwards. We've also got LiDAR and radar mounted on the cockpit as well. So all of these can form a picture of where you are on the earth, where you are on the track, and it uses these different technologies in order to accumulate that knowledge, and then that's communicated into the computer. It's fused, and the job of the coders is to take all of that data and give the signals to the actuation system in order to drive. Now, in addition to this, which is the specific autonomous perception capability and autonomous actuation, we have all of the other sort of engine control data and all the car performance data that you would expect to see on a regular Formula car. So in essence, what we've done is we've taken the driver out, put him in the garage, given him the job of doing the programming, and put the whole backroom team and all the data that they get into the car. So that the difference is the driver or the coder in this instance cannot make any changes during the race. That car must actually figure out what to do itself on the basis of the coding that's given, but also on the basis of the learning that has occurred in the weeks that it's been on the track beforehand. And that's an essential component, and it's very different to what you see in regular Formula races where, the teams will come in the week before and get ready for the race. We've had the teams here since the beginning of March, training on the track itself.
Yeah, with some of the drivers I've had, it's not a bad thing to leave them in the garage, I must admit. But
True.
Anyway, the circuit itself, is there any changes to the circuit to be able to to receive signals or send signals to the car?
Sure. So, well, the one thing that the circuit, it does have a tunnel out of the pits, and we're not going to use the tunnel for the pits in this particular race. However, one of the things that we're going to do is we're going to do a demonstration of man versus machine on the day. Not one of the teams, our own development team here, are going to do that, and they are going to demonstrate their capability to operate in blind under the tunnel without GPS, for example. And so we're going to operate from the pit support lanes rather than the main pit lanes in order to actuate the race. We have put a lot of investment into the track. We have laid new fibre around the track. And normally for Formula One, they just lay temporary fibre for the race, but we've actually built a new infrastructure around the track to increase the actual amount of data that can be transmitted. And we're doing that for a number of purposes, as well as being able to use it for the collection of data for the management of performance of the car race itself. We're also building in a fairly high level of data management for the broadcasting we're going to do. As Ed said, we're going to be broadcasting on the YouTube channel, but we're also going back to my whole point about what we're trying to do here is we're trying to bring the consumer along. We want people to be very active and involved in this. We don't see really us seeking to compete with motorsport in terms of the on-site crowd at a race in the broadcasting. We want to change that. Now, we are going to have a big crowd at this particular event, but our main focus will be online. And so to that extent, we have built a special VR app capability so that people can, for example, put on their VR headsets and have the experience of being inside in that car and being in possession of all of it. It's a very extensive VR app we've developed. I know Apple announced in recent months a mock-up of what they're going to do. Well, we've actually developed the full thing and we're going to deploy it at the end of the month. We've also developed an app where people can go into the app to book in to come to the event, but also to actually see the broadcast and ultimately be able to engage in a gaming experience. So over time, we will see ourselves having live races where people can go into those cars and race in real time against those cars. So we want to see that experience as being a hands-on experience. It's obviously directed at a demographic that's younger and growing, but we see, they're the drivers of the future and they're the ones we want to engage in the experience of the event.
Yeah, part of my main question there was the fact, will the car and the track talk to each other to allow it to have positioning sense from the track itself as opposed to from satellites or other?
Okay, so what you mean? Do we have special posts put in so that it's actually looking its way around? No, what the car has the full coordinates of the track built into it, but there is no special equipment around the track that will help it to navigate itself around the track, right? So it has to rely entirely on the GPS and on the cameras and on the radar and the lidar in order to find its way around, and the learning it does on the track. So it has to develop its own localization capabilities. So the first thing up when people are programming is they have to figure out how to get the car started, how to get it moving. Then the next thing they've got to do is they've got to learn that track. That is the localization part of the programming. And then the next part is the actual racing line, the actual planning module that they have to put into it. But no, that's one of the grounds on which you have to compete. The ability of your car to learn that track, as well as the ability of your car, ability of you as a programmer to teach the car how to actually race competitively.
And the technology and hardware, is that commercially available equipment that you're using, or are you actually developing that equipment on the way?
Well, the way in which we've combined it, we've developed it along the way. So obviously the components that we've used, some of the components have been designed specifically for us. Some of them are pretty much bought off the shelf. So obviously the actuation system has been designed specifically for us by Mechanica 43. The putting together of what we call the electronic skid is designed for us by Denisi. So the way in which we've designed that and fitted together has been designed on the bench by them in the first instance. And then we add the components onto it. Obviously our choice of things like computer, our choice of things like cameras and radar and lidar. We have experimented with different ones to meet our purpose. And obviously, the computers that you're using here are computers, I guess, the computers that you're using here normally sit in a stack somewhere in an air-conditioned environment. That's a particular challenge for it getting bumped around the track at over 200 kilometers an hour in extreme heat. So we've also had to design a way of actually cooling that computer. Involved putting some slits in the nose of the car and bringing air in through that and filtering the air in. So the design of the way in which we put it together is something that we've had to design ourselves, but the actual components are pretty much off the shelf. But the real trick is actually putting the components together, as you can well imagine. And the little things that cause big trouble are quite interesting. For example, the shielding of cables and things like that becomes a really big issue, something that you wouldn't start off thinking about. But it's actually some of the basic things of putting the components together has been some of the big challenge for us.
Yeah, in Formula One, it's always been looked at that the technology can be moved forward so fast because the budgets are so big.
Yeah.
To allow them to exploit different avenues, and we've seen that quite a lot, especially now with the hybrid packages on the Formula One cars. But the reality is, it's the difference in the cost of a battery pack, for example, for a Formula One car and a battery pack for a road car, it's huge and massively different, tenfold if not hundredfold. Do you use, that's really my question, I suppose, is the equipment you're using, is it going to be financially viable for to fit into your, Hyundai, whatever? Mm-hmm. Because that's obviously where it's going to end up in. Once you've proven the product, it's got to end up somewhere in the road car world at a much, much reduced cost to what Formula One could supply it for.
Absolutely, and it's that extent to which we have, when I say we developed and designed components, we've designed them to put the thing, as I would put it, to design it to fit into the car. So the actual individual components are not in and of themselves overly expensive. We're using regular production perception capabilities. So I don't think any of the technology that we're putting into the car would be a significant cost element compared to production cars at the moment. So you're not, to be honest, one of our biggest challenges was putting in an alternator into the car that would generate the power that we needed, and the problems that caused us for our various pulley belts and things like that. So a lot of the stuff that we've had to fix to get this to this point is actually not high cost. It's more the ingenuity of engineers and mechanics to get this thing right. Obviously, the car itself is the most expensive element of the thing, but the stack. Obviously, going down the road, we're going to want to design this stack more efficiently in order to be able to deal with the tolerances that we wanted to take. But there's nothing mad expensive about the way in which we've put the components together here. And one of our objectives down the road is to move to a situation where you reduce the number of components. And I know I was at a conference back in December, and one of the big OEMs was talking about their efforts to switch out some of the perception components that are guiding their systems. And it was kind of interesting because it's something that we want to do, is we really want to open the car as a platform for experiment in future years. This year, the teams can't touch the car. They can't bring mechanics and touch the car. It's only the teams that we put in place can touch the car. So the only variable is the programming. What we like to see happen in the long term is that we open the car to manufacturers, component manufacturers, to come and say, look, we believe that the technology for perception that we have is a little bit better than what you're using. Can you trial it on the car? And then we use the races as ways of testing the capabilities of this technology, again, at high speeds and extreme conditions. So it's kind of like, people launch the space lab, and an awful lot of what happens up there is experiments that are designed to be done in extreme environments. We see the car as our test bed. When we talk about test bed facilities for the auto industry, we think about big tracks and we think about dynamic zones and slip hills and whatever. Here we see this car itself as the test bed where we can test out different sorts of autonomous technology in extreme conditions. So, ultimately, if we're successful over the next decade, you're seeing situations where we reduce the reliance on components and therefore ultimately make this more cost effective.
So, in normal racing, as we know it, the hero is the driver. That's what the public relate to.
Indeed, yeah.
90% of the time, and to a certain extent the team. But obviously, you're moving that away from having a hero driver to a hero engineer, I suppose, or a software technician, a coder. Yeah. How do you see that being represented? How do you get that message across to the public, I suppose it's called?
Yeah, we've invested in an awful lot of effort in the actual presentations. In broadcast, we want to bring out the people from behind the machine, so to speak, the coders. Obviously, there's a difference here. The big thing about a driver in a car, it's a gladiatorial competition. You put somebody in that has specific physical capabilities and skills that are very, very rare. You put them into a machine where they're sitting inches from the ground going at amazing speeds. That sort of raw excitement is something that we don't wish to replace. We think that's something that should always go on, nor can we replicate it. So it's a very different sort of experience where we're bringing out the heroes as the kids that are the coders, and we're going to have to project that across online platforms and social media platforms that are now used more by kids. rather than say, well, my generation, right? So that means that you're getting people engaged, as I said, through the VR experience, through the game experience, through the online gaming environment of Fortnite, for example, like that. So the heroes become so much more the capabilities that are developed. And obviously, in many cases, those heroes won't be people. I mean, they will be the people who perform best on the online environment. But in the short term, we're putting a lot of effort into bringing out the coders from behind the machine. We're projecting them out through our social media channels. We're projecting them out through the broadcastings we're trying to do. But I think when you're looking at the development of heroes in the world of the next decade, next quarter century, I think you got to think about that audience that is coming along, those kids that are coming along, and how they engage in entertainment. And I guess we're future-proofing for that environment. Now, one of the things we're doing as well is engaging the kids directly. So we have a STEM-based competition for teenagers that's running at the same time, where we're using 1/8 size cars, not open wheel racers now, but these are racers that are, the kind of cars that are used in radio control cars. So we've put autonomous capabilities into those, put on educational programs in coding for kids, and they will race on a karting track during the final race day. Longer term, we see teams that come from all over the world. We encourage them to have feeder STEM competitions into the main race and bring those kids from all over the world to our races, so that they're actually actively got skin in the game themselves. They're racing themselves, because these teenagers are they're the drivers, they're the consumers of the next quarter century. So I think what we're seeing to develop here is something that's going to come to maturity over the coming decade. We want to engage those consumers very much on the terms at which they are going to engage with motorsport in the future, which I think is online and gaming.
We often look at one good racing driver compared to another good racing driver, be it about how he reacts to different situations. No two situations are exactly the same. Do you think that with autonomous control of these vehicles that you can get to a level where you can read a new situation and react to it quickly enough or comprehensively enough, as a racing driver has to whenever he's obviously in a situation of overtaking or in traffic at the first lap of a Grand Prix? Or is that something that you can simulate and will be simulating to try to see if you can cope with that?
That's a really interesting question, Gary, because I think the first thing is that when it comes to coding, I think the personality of the coder differs, and that's reflected in the code. So just like the personality of a driver and how a driver will respond to a situation is different. So I think one of the things that we're trying to do is bring out in the broadcast and in the commentary and the expert analysis is to try to look for those trends. Going down the road and going to a situation where, we want a situation where in years to come, we're going to fill a grid of cars, ultimately 20 cars in a grid, and get them all racing towards the first bend. And how are we going to see different cars respond? I think it's going to be driven by the personality of the coder. But I think what we're going to see in time is how the artificial intelligence component feeds into that in order to see what the learning and reaction is. We build over time, but one of the things that you do see is the more and more you practice, the more and more the code adjusts to take account of the conditions that it encounters. We got to do that in a sequential way. But I will be confident that over time that we will see that kind of learning develop. But we can't fool ourselves and believe that's going to happen immediately. I mean, one person said to me, gosh, isn't this going to be completely boring? It's just going to be perfect races all the time. Everything will be perfect. And I don't think so. And it actually is an interesting insight into where AI is going, because over the last couple of years since the launch of GPT, everybody has thought, gosh, are all our jobs going to be replaced? Now we can just get this to write an article for us, or this to do my job, or this to be my lawyer in court. And I think we're still quite a distance away from believing that generative AI is going to be able to do all of the things that a top-class Formula One driver can do. And I think one part of our process here is to take this in a step-by-step process to see how that learning goes along. I think the inherent skills that are there are not ones that are easily programmed, are not ones that are easily learned. And I think the journey of the coming years will be of interest to us in discovering what the potential and the limits of AI are as much as anything else. Because, we don't want to hand over co-piloting of our cars to something that's unpredictable. So there's a lot to learn. And the simple answer is, I don't know how it's going to happen in the short term. But I believe there's going to be, some interesting learning along the way, some hiccups along the way. But I think the interesting thing about this platform is the one where I don't believe you can say, hey, everything is going to be perfect straight away because the AI can do it all. I think there's going to be a steep learning curve for the AI to get to the level at which the human can do now.
Well, you're taking on a huge challenge, and it's going to be a fairly public challenge because a lot of people, including the OEMs, will be looking at how you address those situations, because that's the next step, is to be able to address those, unplanned situations, I think is the best way of putting it.
Absolutely, yeah. And I mean, we see some of that in practice at the moment. We see it with the teams. We've taken a very step-by-step approach. This is there has been autonomous racing before. The Indy and Robo Race have done autonomous racing, and we're building on the shoulders of their achievements. But the number of things and the challenge we've given us here are enormous, because the car we're using is an incredibly complicated car in the first instance, way more than was done before, and we're doing it on a road track. So yeah, this is a high risk experiment that we're undertaking. But what we're really committed to is that we're not in it for the short term. We have started out by saying, look, we're going to do an annual race in Abu Dhabi for the next 4 years with the same prize purse that we're offering this year. And our steady state objective is to have 3 races a year, and one in Abu Dhabi.
So that's the plan, is to have an actual championship as such over the season.
Yeah, and the idea to have it be international. So the working idea is to have one in Europe, to have one in Abu Dhabi, and to have one in Asia, being the way we go forward. And to that end, we've, as well as building up the car and building up the teams and building up the local circuit here, we've also been building up a sponsorship backbone to enable us to build a business model to push this forward. And of course, motorsport is our launch pad, but the Abu Dhabi Autonomous Racing League seeks to be active across land, air and sea, and land on track and land on off-road. So we will shortly launch our second platform, which will be autonomous drone racing. Different sort of use cases. I think some of those use cases will be seen more in the developing world, where you see the need to have methods of transport that don't use roads and that do need high value goods to be transferred in a very rapid way. And similarly with off-road vehicles and with seagoing vehicles, there are different use cases. So we're trying to build an ecosystem here. There'll be a lot of challenges along the way, but I don't think it's one of those things where if you really want progress to come in solving big problems, you've got to take the risks. There are a number of entities in the world, not that many, that run things like grand challenges, like we do, to solve big problems. And sometimes it takes a long time to get to the solution. And I think the best example is, we all take our heritage from the original Longitude Prize from the early 18th century in the UK. And remember, that was trying to solve a big safety problem as well. 20% of all shipping was foundering because of the inability to calculate longitude at sea. And, that was a big loss of life, a big loss of wealth in terms of the cargo that was being brought. But when that prize was launched with an act of parliament, it was 14 years before a successful prototype was brought together. And then, even then, it was another 50 years between the ultimate clock was developed. So when you take on huge challenges, you got to recognize that you're not necessarily going to always succeed at the first step. But what you're trying to do is you're trying to bring forward a level of development that will occur at some time in the future. But if you can, make some make some contribution by making that happen 5 or 10 years earlier than it otherwise would, then think about it. The number of people that may be alive 20 years from now as a consequence of that would be huge. So we're driven by trying to solve big challenges. We're using extreme sport in this instance as the platform to try to do some of that. But our focus is on the big problem that's behind it. And we do recognize that you have to be audacious, you have to be risk-taking in order to bring about the kind of change that we have seen. I mean, I was actually quite horrified when I started looking at statistics on accidents and fatalities across the world, and I was motivated. In some respects, I was looking at fatalities in my home country, Ireland, in recent years, where there had been a steep drop in fatalities, and then they started turning up again, and it was like really worrying. We have safer cars, we have safer roads, and yet we are seeing a stubborn persistence of accidents and fatalities. And I think we do have to start turning to primary safety when it comes to road vehicles, and we have to learn from motorsport there. I'm not offering a simple solution. We're not seeking to push out regular motorsport. We're seeking to create something that's different, probably more appealing to a younger and emerging generation. But our big motivation is, at the end of the day, is to actually promote road safety.
So you're just over 14 days away from your first event, I suppose you might call it. How is it going at the moment? What's happening today, for example?
Okay, so today is a rest and recuperation day for the teams themselves. They had a track day performance yesterday. They're back on track again tomorrow. Then they sort of do their analysis again Thursday, Friday. And then once they get into next Monday, they're on track every single day from the 15th right through to the 27th, 9 a.m. in the morning to midnight. So their performance has come on really well. Yesterday was a good day. Some of the lap times I saw put in were ahead of where I thought they would be. So that's some pretty good performance being demonstrated. In terms of us, an awful lot of the work is around the ancillary activity that's going on for now. I mean, they essentially leave the people in the garage alone. We put a lot of effort into building up the garages. Each of the teams have their own garage. They've got their own data center behind the garage. They're all living quite close by, working kind of hard. Our chief engineer is marshalling everything that's going on there, and that's going, we've got some really talented people that we brought in on the engineering and the mechanics side and the race management side, which is, the best thing is to leave good people alone, is my view, when you manage these things. A lot of my focus is on the ancillary activities. So we are doing a big event as well to showcase here. So we're leaving up to 10,000 people in for this. We put together a big fan zone. That fan zone has a lot of activations that are related to autonomy. We're building an immersive museum experience, or Racium, as the event people are calling it. We've also got Sony coming in with the Gran Turismo simulators, so that we have that in the fan zone. We have VR demonstration in the fan zone, other kids' activities in the fan zone. Obviously, the STEM race will be done alongside the fan zone. And then we have after race entertainment and concert. We're getting the broadcast teams in place. The actual, the local media drive is on. The final developments around infrastructure around the track and preparations and race management and communication. So there's a hell of a lot of detail going on. It's a very long Excel sheet with all the project management. But I think a lot of this is giving the teams the space at the moment. They're obviously intensively working in their preparation, but a lot of my focus is around the ancillary supports to make the whole day look and feel good. As well as I'm not the one that's going to be programming, I'm not the one that's going to be maintaining the cars, but my job is to make sure that everybody has what they need, and then trusting good people I think we've got a fantastic support team that we've built up. The competitor teams are really, really impressive bunch of people that have been brought in from, some have, are bringing the motor racing heritage, obviously from Motor Valley in Italy. Others are from places where there isn't such a heritage. But they're an interesting combination of teams put together. They're cooperating a lot, because scientists work by cooperating and then competing to get the paper out. So in the same way here, they're cooperating. I think over the coming weeks, as competition gets a little bit tighter, this will probably get to the point at which they probably won't be sharing quite as much as they move into it. But yeah, it's incredibly busy. This is technically a holiday week here in Abu Dhabi for Eid, but I don't think many of us are taking holidays. It's certainly the people down the track aren't.
Well, I'm certainly looking forward to it, and I'll be keen to watch it on the Races YouTube channel to see how it all unfolds, because it sounds like a massively interesting project for the engineering side of motorsport.
Yeah, and we have a conference the day after as well, Gary, where we are... there's no point in us talking about this vision and just doing the race and the experiment. We need to reflect on what we do. So the day after, we put together a pretty packed agenda. We're looking at a number of things on that conference, and we're bringing in industry as well as the motorsport into it. And so the first thing we're looking at is that actual gap between potential of autonomy and actual adoption. We're bringing, we're looking at this from the safety point of view, from the consumer acceptance point of view, from the connectivity challenges that exist, if we're going to use roads. Then we're also going to look at the gamification and online experience of that. So we've got some of the industry leaders coming in to talk about their experience and talk about the one we're using. We're then bringing in a lot of people from motorsport engineering to look at innovation cycles in motorsport. I've read a lot, looked at various case studies of that supply chain, of that value chain in innovation in motorsport. And what you got to figure is, how do we enhance and build into that innovation cycle the autonomous components? Because the one lesson that we learned very quickly is we were focusing a lot on the autonomous component, assuming everything else was fixed. But it doesn't work like that. This is a general entire system. So when you change one thing on the car designed for a human driver and put in this other stack, then there are other knock-on effects. So you have to look at the development and innovation cycle in its entirety. To that end, we will also be looking at how we integrate this with future engine development. We've chosen a fairly standard Honda engine to go into this, but we decided against using electric vehicles. We wanted to maintain the noise and gut feeling that you get on the banging that goes with a petrol engine. But we do want to look at other what I call it, innovations here, other kind of fuel cells, hydrogen type cells that you might use in the engines of the future. So in terms of our innovation cycle, we want to integrate autonomous development to the regular innovation cycle. And then we'll also be looking at doing a review of the race and looking at the open research questions and how they can be translated into the designs of the race. So we're going to spend a lot of time the day after in that conference, and we hope over time that conference will itself become the annual check-in for where we are and going to that path of achieving the big vision we have for this. So that we want to stay laser focused on why we started doing this, and then measure our progress year to year as we get there. Be very honest in where we have failed. Be very clear in what next steps we have to take in order to make that progress. But continue focused on what our goal is, to bring the future potential closer to current usage. And then I think we're going to take a few days off afterwards.
Okay, Tom, well, thank you very much for your time, and I really do wish you all the best for your first event.
Thank you so much, Gary. I appreciate you taking the time, and I really appreciate the questions. Great to see you again too, Ed.
Yeah, well, thanks very much for the insight. If I may just ask one final sign-off question, because I think people will be wondering if they're listening, about if we were to say, well, obviously, as you said, it's a rest and recuperation day, but if we brought back a team and said, right, put the car on track, give it your best shot, what sort of thing would they see? Because everybody's going to be asking, how quick can these cars go over a single lap? Because we know Super Formula cars are very quick. Mm-hmm. So what roughly would we see from a car going at its best pace around the track today?
Okay, well we're going to... We have done that spectacle, right? So our own development team here in Technology Innovation Institute, TII, have been developing pushing the car to its maximum speed. And we're going to bring Danny Kvyat, who has been driving the human-driven car for us, and we're going to put him on track together, Danny versus the autonomous one. I know exactly what best lap Danny has done at the moment. I know what best lap they have done. There's a gap. And I'm not going to reveal exactly, but the gap is falling. And we're going to... So at the moment, if I can see a 30% increase, a reduction in that gap, I would think that's going to be a hell of a show to demonstrate. So that's what I'm hoping to demonstrate to them on the in between the speed race and in between the final race. But I also know that our competitor teams have an eye on trying to keep pace with that as well. But I was smiling earlier with the times I saw yesterday. And I was highly encouraged by the speeds that have been shown. And so that's what I'm hoping they're going to see. They're going to see some very significant improvement in the gap between what the human can do and the autonomous car can do over a road track, which is no mean feat.
Excellent. Well, I'm looking forward to seeing that. So thanks very much, Gary. Thanks very much to Dr. Tom McCarthy as well. Hope the rest of the month goes well. I'm sure it's very busy. And to everyone listening, we hope you enjoy this bonus episode on autonomous racing. We'll be back soon with another F1 focused episode.